Welcome to this tutorial. Today I will take you through the configuration settings of the Campbell operation. I've started IPEmotion and I'm working in the Data Manager workspace. A sample dataset is loaded, which includes a 50 kHz sound measurement recorded from microphones and the engine RPM measurement measured from the vehicle CAN bus. I'm switching now to the Operations tab sheet and create a Campbell operation. The Campbell operation is processing the data of the source channel head microphone middle by calculating multiple FFTs which will be presented in a Campbell diagram. Now we will have a look to the main configuration settings of the Campbell operation. The source channel is already defined and it is indicated that it was recorded with a 50 kHz sample rate. On the resolution drop-down box, you define how many data points are integrated to the FFT calculation. When you take many samples, you increase the resolution of the FFT and the analysis features of the Campbell diagram. The frequency resolution is directly indicated here in this gray text message box. In this example, it is 12 Hz. With the reference variable checkbox, you can select any channel from the data file as the reference for the FFT calculation. As the screenshot indicates, rather than computing time-based FFTs, they can be related to the selected reference channel, which should have a correlating impact to the noise or vibration excitation levels. In automotive application, the noise level is usually correlating with the engine RPM. The reference monotony, increasing or decreasing, is a relevant setting for the FFT calculation to indicate whether the selected reference channel, like in our case the engine RPM, is increasing or decreasing. As the animation screenshot shows, all non-monotone dataset points are excluded from the FFT processing. The step definition overlap setting can be defined in percentage or in absolute values. When you select a reference channel, it has to be defined in absolute values. The screenshot above compares a different resolution in a Campbell diagram using a 1 RPM or a 100 RPM step size. In essence, a high overlap or a small step size is increasing the time-based resolution. In the Pre-Filter tab sheet, you can define different filter modes, low pass, high pass, band pass, and so on, to cut off specific frequency ranges. As indicated in the example above, there are two Campbell diagrams compared, where one diagram is using a 500 Hz low-pass filter. In essence, all frequency components over 500 Hz are damped and don't show up in the Campbell diagram. Finally, I would like to draw your attention to the weighting tab sheet. There are different weighting methods supported for dB unweighted A and C weighted functions. It is important to relate the FFT amplitude calculation to acoustic standards. For example, for our airborne noise measurements recorded with a microphone, an A weighting is required with a reference value of 0.0002 Pascal. The reference value is depending on the type of measurement and the application, and it is required to compare the Campbell output results. I hope you will enjoy working with the Campbell analysis function. Thank you very much for your attention.